Charlie, thanks so much for being on the show with us today. Before we get into it, I always like to have people introduce themselves so they know who they're listening to. Charlie, if you wouldn't mind, just tell people who you are and what you do here.
Yeah, I'm Charlie. I'm the CEO and one of the co-founders of Berd. And despite coming from a chemical engineering background, now I'm the CEO of Berd Spokes, and I've been doing this full time for about 7 years.
And Berd, I think if I remember correctly, you said you've been around for you kind of started playing with this for 10
years ago? Yeah. We started the company right at the tail end of my graduate school, which was in 2015. And I founded the company along with two good friends of mine, Brad and Kyle. And we initially started part-time for about 3 years until I was able to quit my full-time job and do it full-time.
Living the dream.
You bet.
So I think a lot of people who are listening to this will be familiar with at least the brand Berd. And I would have to think that the vast majority of those people, when they think of Berd, they're thinking of spokes, right? So that's still the primary part of your business, right? What exactly is that part of the business?
Yeah, exactly. Well, we started out with just our spokes, right? So we started with white spokes, and we've slowly been growing the brand since then. We moved to black spokes and then developing our whole line of wheels. But as part of this process and as part of the development of our company, we had to find a way to be able to produce our spokes. There was no way that existed to do that previously. There was no manufacturing for a braided fiber spoke. You can't do it with an injection molding process or with a metal stamping process or anything like that. And we got a grant from the National Science Foundation to create automated machinery to be able to produce these here in Hopkins, Minnesota. So we spent many years going through that process of automating the spoke manufacturing. And as part of that, we've sort of become a technology company. And we'll talk about it more, but that's how we sort of spawned the idea of creating our automated truing machine that's now called TRUDI.
Ah, yes, this thing that we happen to be sitting next to, right? This big old contraption. Am I remembering correctly that the name of the company was Berd Spokes, or has it always been Berd Technology?
The name of the company is neither of those, actually. The name of the company is actually just Berd. It's Berd LLC. And as much as I'd love to have Berd.com, it's just too expensive for us to afford. So Berd Spokes has always been the website for our spokes and our wheels, and now we have a new website, Berd Technology, which we host everything TRUDI related.
Okay, well, I guess that's where I'm thinking of that from. So this thing that we're sitting next to, I guess to me it feels like a pretty big evolution of where your company is going now. So, like you were saying, you originally started with these Poly-Lite braided fiber spokes, and they're what is it, ultra high molecular weight polyethylene? Is that right?
You got it.
Okay.
I can tell you have a material science background.
Maybe, and so I even remember some of it. So you started with the spokes alone, then you went into complete wheel sets, and now you're here. So what is this thing that we're sitting next to?
So this machine it's a revolutionary wheel truing technology. And what it does is it takes a complete picture of the wheel. And so we put a wheel in here. It measures the lateral, the radial, the dish, the tension variation. And instead of the normal process of truing wheels, which is an iterative process that's oftentimes done by hand, this process is after measuring the wheel, it actually computes exactly what to do to true the wheel so that then you can go around in one single pass with an automated driver that's been programmed with those results to, almost magically be able to true a wheel without having to know how to do that in advance.
That sounds pretty appealing. So I guess, can you tell me a little bit more about when you say you take a picture of the wheel, what do you mean by that?
So we have sensors that contact the rim. So there's a lateral sensor. The lateral sensor measures the rim as it moves left and right in the stand. There's a radial sensor that measures the up and down movement of the rim. So the first one was lateral run out and then radial run out. There's a tensiometer that measures, with the assistance of the operator to put that on each of the spoke, measures the tension of every spoke. So now we've got the lateral run out as it goes around the wheel, the radial run out as it goes around the wheel, the tension of every spoke. And then by flipping the wheel in the stand, we can measure the dish of the wheel. So that's what I describe as the complete picture. Understanding all those properties sort of in this digital space that you can then, that then the algorithm can then figure out how to make the wheel true by adjusting each spoke.
I mean, I guess, would it be analogous to what a traditional mechanic would do by sort of just putting a wheel in a truing stand and just kind of spinning it and taking a look at it and kind of like squeezing the spokes and that sort of thing?
Yeah, so the end result is the same, right? There's basically one optimal end result to get a wheel to that is within all of your specifications if you're good at what you're doing. But the way of getting there is different. That's the different part, because the normal process to true a wheel is to do it iteratively, where you make an adjustment, you see how that fixed the wheel, you make another adjustment, you see how that fixed the wheel, and throughout that process you end up touching each spoke many times to do it that way. And the reason it's iterative is because even if you're the best wheel builder and you can understand how the wheel reacts, you might be able to simultaneously fix all those things at the same time. So maybe you can do an adjustment that fixes the lateral movement, it fixes the radial runout, it fixes the tension, in one portion of the wheel. But even if you're the very best at doing that, you might not still fully understand how does that actually also affect the other side of the wheel, and how does that affect the spokes 3 spokes away from it. And that's where you're so thinking about it and doing it manually, you're sort of limited by your ability to just understand how it changes everything at the same time.
So would it be safe to assume that basically after TRUDI takes this digital snapshot of the wheel, and then you have this automated motorized driver that you use to turn all the nipples, and as far as how the system knows how much to turn these nipples, I mean, I guess it's just a bunch of math.
Just a bunch of math, and that's really the secret behind it. That's really the part that we've spent so much time working on over the last 3 years to figure out. And having 3 founders as part of this company and a lot of other people with advanced degrees in math and engineering, we've been able to solve a lot of these challenges along the way. And not to say that there weren't things that we've built upon on the past, which I think I should tell you a little bit more about, but the amount of work that we've done in the last 3 years to figure out all of these models and the way the algorithm works has been honestly just surprising how complex wheels are and what it takes to actually make that happen.
Because as someone who, I mean, I haven't built wheels regularly in quite a long time now, but I certainly used to build a fair number of wheels and definitely was truing wheels all the time and stuff. Conceptually, I think a lot of people can maybe at least have the idea that a perfectly true and straight wheel should be kind of simple theoretically, right? You have a hub that's suspended in the middle of a rim, perfectly centered both left and right and radially. And then as long as all the components are the way that they're supposed to be, then all the spokes should be perfectly tensioned. Like in theory, it's pretty straightforward, right? So like why is this such a difficult thing to solve?
Well, in the end, the end result is there's sort of only one end result.
The straight and round wheel.
The straight and round wheel. Although you have to remember that nothing is perfectly straight and round, and everything has some sort of variation. And so in the end, you are balancing all of these things. And the way we do it, I think, is similar to the way anyone would build a wheel by hand, where you've got some sort of specification in mind to begin with. So you might say, I would like my lateral to be within 0.4 millimeters. I want my radial to be within 0.4 millimeters to run out. I want to have plus or minus 10% of variation in the tensions, for example. And then what you might do is you might bring all of those things down sort of simultaneously. You're not trying to get one a lot better than the other. You're sort of trying to get them all down to their specification. And then if the rim is good enough, if you're able to, then you can continue further to bring them all down further to make them even better than your specification, sorted in even amount. And so if we agree that is sort of the best, what you're targeting, and that's of course what we've programmed into TRUDI, and you have to boil it down to one thing. You have to have one number to say this is the goodness of the wheel, so that what is it that you can do that'll make it better. What is it that you'll do to it that makes it worse? But once we agree on that, that being the best result, then then TRUDI can get there, and then the best wheel builder will be able to get to the same place also.
How are you determining what makes for a good wheel? Because to some extent, I mean, aside from the physical dimensions of straightness and roundness, that sort of thing, like how are you? I guess how are you defining that? Like, are there sort of factory presets, or is that something that you can define manually? Like, how are you determining, or how are you deciding what's good?
Yeah, well, we have general guidelines that we use, in our manufacturing, which are similar to all the other manufacturers what they use, and those are the preset. That's the place that you start for any wheel, and if people have other guidelines that they'd like to go by, then they can change that in the program as well.
Is this meant to? Well, is this meant to replace something? Is it meant to supplement something? Like what is your goal with this? Like what was your motivation for making this thing in general?
Yeah, well, I'm glad you asked. So we started on this project with TRUDI about 3 years ago, and at the time it began with Nick, our wheel department manager. At first, he just wanted a better driver, so that we could have a programmable driver and just be able to do a half a turn at a time or one turn at a time to make wheel building easier, just to supplement our wheel building process. And so it started as a very basic tool to be able to improve our wheel production here at Berd. And then, at some point I had the idea, I think we can take this further. In fact, I think we can take it a lot further to automate and get to where we are today with this for our own internal production. So when we started on it, we had no intentions to use it elsewhere. It was really just for our own production that now we've been using for about 2.5 years. Starting as sort of a very Frankenstein looking machine, with gauges mounted to a traditional stand. But then we realized the benefit that this might have for metal spoked wheels, and that's when we started. As much as I didn't want to, right? We started bringing in metal spoked wheels into the Berd.
Because you don't build any metal spoked wheels here, right? Like it's like
No.
It's the heart of your brand. these braided fiber wheels, right?
No, we do a lot of unbuilding of metal spoked wheels, but we don't and replacing, but we don't typically build many metal spoked wheels. But we realized the benefit that this would have to the majority of wheels out there, which of course are still built out of metal. And that's when we started seeing the benefit of the machine for for others, and ultimately we're working on a better tool. It is a tool that makes it easier to build wheels, that makes it faster to build wheels, that supplements somebody who's already a great wheel builder. It supplements somebody who is just learning how to build or true wheels, and that's. When we have a better tool that others can benefit from it, then we want to be able to get it out there.
So from a production standpoint, obviously, one of the main goals from a production standpoint, obviously, is just to be able to make more wheels in a given period of time, or just make a certain wheel faster. Do you feel like this makes a better wheel than what you were doing previously?
It does. It definitely does make a better wheel than we were doing previously. The reason for that is just the consistency of it. You're even if you're on your game or you're not on your game, you're still getting a really good wheel. You can imagine if your job is to build wheels full time all day in production, there might be moments when you're really efficient at the beginning of the day, and then maybe fatigue sets in after lunch, and things don't come out quite so good after that. So
right, or you're kind of in a bad mood, or you're just having a bad day, your wrist is tired, something.
Yeah, but honestly, but with them, in the end, when you have a QC process at the end of a manufacturing process, and you're rejecting things that don't make it through anyways, then it mostly just comes down to efficiency. And for us, we could true 3 or 4 sets of Berd wheels in a day, and now we can. One operator can do about 13 sets of wheels with TRUDI.
So that's like a 3-4x time.
Yeah.
TRUDI, from what I understand, at least from a production standpoint, TRUDI is not. there are other companies like Holland Mechanics. Some people may have heard of them. Like they make kind of more industrial scale automated wheel building machines where you basically sort of feed in a bunch of rims, spokes, and hubs into one end of the machine and push a button, and essentially like it just builds a wheel and a wheel gets spit out the back, right?
Close. So, with Holland machines, and, this gives me an opportunity to kind of give you the whole history, right? To give you some of this history and science of how some of these things have evolved over time, because what we're doing here it's definitely new. We've combined a lot of new things. We've spent a lot of resources, a lot of time, but at the same time, we've built on all of the things that brilliant people have created over the last 50 years. So starting from the traditional way of truing wheels, one of those big developments was the machines from Holland and from Bikebotics, and they've been making those machines, I think, for at least 50 years. And as I go through this history here, I'm sure that somebody is going to say I missed something, so I apologize in advance for that. But
no one's perfect, Charlie. No one's perfect.
Just like a wheel, right? So Holland machines, they have a variety of different machines for the wheel processes, right? There's machines for hub lacing, for hub filling. There's machines for rim lacing, for connecting the rim to all the spokes. And then, of course, there's the automated truing machines. And the way the automated truing machines work are the wheel rolls into the machine, it measures the wheel. But what's really interesting about Holland machines and Bikebotics machines, and again, somebody can correct me here if I'm wrong, but that these machines actually still use an iterative process for truing them. So they don't actually use the algorithms that we've developed now that take one picture of the wheel and then are able to just touch each spoke once and get the wheel pretty much finished in one round. And so anyways, I'll come back to that a little bit more. But so Holland machines are great. They're a wonderful tool. They're about a $100,000 to $200,000 machine. They take up some real estate, and quite frankly, most of the especially aluminum rim wheels are made by that type of machine. Whether it's in Taiwan or China or here in the United States too. Some of the downsides though with those machines are that they do take some time to set up. So if you're doing a variety of different wheels, the setup time just might not be worth the time that you get savings on those. The other thing with the machines is that they aren't able to reach the specs required for carbon wheels.
Why is that? Because I think just to back up a little bit, you do hear a lot about sort of like hand-built wheels or machine-built wheels or hand-finished, which is kind of like a bigger thing that's coming out right now. And it does seem like a lot of those things are basically ways for brands to kind of put forth the idea that like some human hands, like some artisan, some skilled technician, like finished these wheels in a sense so that you have a wheel set that is supposedly equal in quality to what you would get from just an experienced wheel builder who did the whole thing from start to finish, right?
Yeah, yeah, and in chemical engineering terms, it's called a state function, where in wheels it doesn't matter how you got from the start to the finish. All that matters is where you're at in the finish. So a wheel started with a Holland machine and finished by hand would be exactly the same as a wheel finished by hand if it was done to the same sort of specifications. The reason I say that they're not good enough for carbon wheels is just because carbon wheels typically require a higher specification on you're buying a more expensive wheel. So manufacturers will have a very tight spec for the run out on the wheel, for the tension balance on the wheel, whereas a less expensive wheel, it's going on a less expensive bike made out of aluminum. The key feature there is speed and efficiency and keeping the cost down on those. So Holland machines, Bikebotics machines are designed to do things efficiently, but they don't necessarily have the tolerances and the lack of slop in the way in which they turn nipples and those sorts of things to be able to get wheels to a really tight final spec.
So this iterative process that you're talking about with these existing wheel trimming machines, is that an inherently bad thing? I mean, it does seem like it would be certainly conceptually less efficient, right? Because that's basically how a lot of things are kind of hand finished anyway. What is this algorithm that you're talking about that you've integrated into TRUDI? You're saying that what it lets you do is, like, after it again takes this digital snapshot of the wheel, that you basically can just touch each spoke once, you're saying, and then it's done, right?
Yeah, and if you have the system perfectly trained for the machine and you don't move your arms at all during do it, you can do it in one round. Practically, oftentimes you do a full round of truing followed by some sort of stress relief, and then you might do one additional round after that. But so the kind of the history of truing then, right, is we've had these automated wheel truing machines for a long time, and there's been many developments over the last 50 years that have sort of led us to be able to get to a place that we could even start thinking about creating TRUDI. And some of those things are the P&K Leah truing stand, which that was a big development in hand truing, which it with the non-linear gauges, it allowed people to start building truing wheels much faster by hand.
Right, and I guess just to recap, when you say non-linear, I guess what for anyone who's not familiar with what you're describing, the way those dial gauges work, they exaggerate small variations directly off of zero, I guess, and then it basically makes it so that you have higher resolution to get a more precise wheel, right?
Yeah, so somebody who's people who know how to use those machines and are good at it can really build wheels so much faster by hand, and especially for the high-end wheels that we talk about that are predominantly hand built. And still today, for example, in Taiwan, so many wheels are still built by hand because of those, of the deficiencies of the fully automated machines to be able to do it, to do it really well in that case.
This algorithm that you're talking about, the calculations that it goes through, how much can you talk about how you do that?
Yeah,
because that does seem to be the sort of the secret sauce here, right?
Well, that's so that's sort of another part of this history is that, and we found this out after we had already independently done pretty much the same thing here at Berd. That somebody named Jim Papadopoulos, he's been involved in bicycle science for a very long time, and he did a PhD at MIT in mathematics, and then he got funding as a postdoc at Cornell to do bicycle science. And
he got funding to do this.
Surprising, right?
Who funded this?
Impressive, I know. How cool is that? Which I feel like might be less likely these days.
Yes, very likely
to get that. And so I first came across his patent a couple of years ago, and Jim was actually the first person, again, correct me if I'm wrong, but he was the first person that I know of to first conceive the idea of truing a wheel in a single pass. And so Jim, as far as I understand, he did this towards the end of his postdoc, and he had this idea. He did some measurements on it. And by the way, this was in 1990, when the sensors and the electronics and the technology wasn't quite as good as it is today. And he wrote a patent on doing it, but he didn't actually have the ability to spend a lot of time on that, to test it, to flesh it out. And so I had a chance to chat with him a little bit about that not too long ago, and he said he wasn't totally sure that it actually worked, because he really never had a chance to fully test it. And now that we've developed it ourselves and gotten kind of years in our own development past what he had first done, we realized there's definitely some missing pieces to what he had done. But I'm sure if he had continued to work on it, or had more time or more funding, or a big need for it, I'm sure he would have also figured that out. But I think we can give him credit for definitely starting that. And then there's been a few other kind of key people and companies that have developed things that we've built upon to get where we are today, including tensiometers, digital tensiometers, Rick at Wheel Fanatic makes a very nice tensiometer with a Jobst Brandt design, which apparently he still has the original one of those that he had dropped off at the bicycle shop one day. And
Of course he does.
and
Rick.
or he has many more things than
I'm
that.
I'm sure.
And Rick, by the way, is just he's been involved in this industry for so long and contributed a lot in many different aspects of wheel building. And then, there's not that, as far as I know, there's not that many people out there that study bicycle wheel science. And we've gotten pretty deep into it now with everything that we do here. Another individual that had the opportunity to do bicycle science as part of a PhD is somebody named Matt Ford, who, as part of a NSF grant, was able to pave his own way and do some research. Also, actually somewhat under the advisement of Jim Papadopoulos, and that was more recent. Matt did that in 2018. But what's interesting, as far as I know, nobody has ever, the patent that Jim first did for this, touring a wheel in a single pass, never was pushed or licensed by Cornell or never used by anybody, and so we're the first one to be able to use that technology in our system.
So the research that Jim did back then, so he had this concept of being able to true wheel in a single pass, and I guess did he have a lot of the math already worked out as far as what needed to be done?
Yeah, definitely for the basics of it. Jim is a mathematician. And so he had the math figured out.
That's what I was guessing. Yeah.
Let's just put it that way. Although we do it a little bit differently, and when you get down to it, and when you do have imperfect things, and when you are balancing between your tension variation, your lateral run out, and radial run out, there's definitely a number of different things we've added to that. Not to mention, you're not always necessarily wanting to do a full true on the wheel where you touch every single spoke. So we've added other pieces on there to the thing that we call quick true on there. So there's a lot that we've done there now to get where we are. The other things that we've done though is we've done a ton of development on all of the hardware and the electronics to make everything work really nice. So we've coming from our background of developing all of our own equipment, we have we now have our new gauges with our own electronics in them. We've designed all of our own PCBs that go on the back of the system, and then of course we do all the software for it too. And we first started with a Windows-based software, and now we're onto an Android software.
I mean, looking at it, so breaking cardinal rule of podcasting, where I'm going to be talking about something that ideally you should be looking at. But looking at it, I mean, it's almost sort of like a glorified truing stand with a tablet attached to it and some digitized sensors and an automated motorized driver. I mean, that's essentially what it is, right? But it does seem like the math really is the key to this whole thing, right? Because, correct me if I'm wrong, but in theory, is there any reason why, like, let's say someone at Holland applied the same concept to the machines that they already have? Could they do something like this with their physical hardware?
For sure. Yeah. We do have some of our own pending patents now too on some of the things we're doing, which is, of course, what we would necessarily do as a company. But absolutely. And that's the thing, is that we have designed some of our own hardware. We have designed some of the ways that the sensors work to make it work really well with our systems. But people have been, Holland and Bikebotics and other people have been measuring wheels for a very long time. And one good way to describe the way the system works is, it is a combination it's somewhere in between a Holland machine and truing wheels by hand. And what it does is it takes the pieces of an automated truing machine that the computer is really good at and has that do those parts, and it takes the pieces of the hand truing machine that an individual is really good at and uses those. So So a computer is really good at calculating exactly what to do, so the computer does that. But the person operating the machine is really good at putting a driver on a spoke. That's actually a really hard part, when you have deep carbon rims, you have different angles. You used the machine here for the first time just a few minutes ago, and you were able to put the driver on the nipples first time, no problem, because you're really good at that. So it does, what people are really good at, people do. What the computer is really good at, people do. And that makes what we think is a really good hybrid between the two. Not to mention, it's a very small cost compared to that of a fully automated truing machine.
Right. So you said earlier that one of those Holland Mechanics setups can be $200,000. What does this thing cost?
$7,000.
That's obviously still a lot more money, or still a lot of money for certain applications, but in an industrial OEM standpoint, like that's not a whole lot.
Yeah.
I mean, you still need a person to kind of operate it, obviously.
Yep.
In terms of time, so I did get to play with this thing a little bit earlier. I kind of went through the process myself, and I've been watching your own guys here building wheels and kind of like roughly timing things. So basically, from you had a separate person who was lacing up the wheel. So which I guess similar to an automated setup, you would have like an automated lacer. But from the time you had a laced wheel in hand to the time you have a fully finished wheel in hand, it was like 3 minutes per truing round, and then you went through like iterative de-stressing. So that's kind of a different process. But the total time from start to finish was like 20 minutes, maybe. What sort of time? So compared to, I guess it's not really entirely fair to compare that timeline to a fully automated setup, because the end result is a little bit different, and for certain wheels, it's not really the same acceptable standards. But are you saying that is sort of both quicker and better than what you would get from like a fully hand built setup?
Yeah. Oh, yeah, for sure. And taking people who are already good at truing wheels and then using TRUDI is it depends, right? It depends on the setup, exactly what fraction of time you're going to save. But I think a good rough estimate is 15 minutes on TRUDI, which allows you to do multiple rounds with de-stressing, compared to 30 to 60 minutes building a wheel completely by hand, and of course longer if you're new to the process.
So who are you saying that this is for? Because I can certainly see how a lot of OEM assembler factories and that sort of thing could see, if nothing else, a lot of cost savings compared to a lot of the industrial stuff that's out there. But like, do you see even like smaller individual wheel building outfits doing this, or like bike shops? I mean, I guess $7,000 is still a fair bit of money. Like, how do you make that? So I guess to come back to that original question, like, who do you anticipate is the customer for this thing?
Well, of course, we started with us as the manufacturer, and then we realized there would be a big benefit for manufacturers. And we have about 10 customers who've been using the machine for about a year, kind of more on that OEM wheel building side. But we realized there's also a big benefit for bike shops, not just on the building wheels. And there's a lot of shops who do build wheels, so being able to do that faster is definitely a benefit. But on the wheel truing side, also there's a big benefit. So even for bicycle shops who are just truing wheels, imagine being able to take a wheel right off a bike, true it in 3 to 5 minutes, for just a quick true, a single pass around the wheel, give it right back to the customer. I think there's a big benefit there, not only in terms of efficiency, but also providing great customer service, maybe even giving them a report or a sticker that goes on the wheel afterwards to say, look, here are the final specifications of your wheel. It was done by TRUDI and our operator here, and it's done perfectly. To be able to say that and prove that to your customer, I think there's some value associated with that also.
I guess a lot of shops would be able to do stuff like that now if they have a good mechanic on hand, right? Like being able to do a quick true on a wheel in 3 to 5 minutes, like that's not really a big deal if you know what you're doing. But it sounds like a big goal of what you have here with TRUDI is that you don't need as much experience or knowledge or just kind of years of wrenching to be able to do this sort of thing? Like who would be able to use this? Like pretty much anybody, or like do you have to have any mechanic experience?
Well, there is more to doing, bike maintenance and to doing wheel evaluation or wheel building than just the truing aspect. So I do think it's important that whoever is using the machine is a trained bike mechanic. They're able to evaluate the safety of anything they're looking at, but at the same time, you don't necessarily have to know or be good at truing. And the sort of fun example to this is that I actually brought this machine to my kids' science fair kickoff last month.
And how old are your kids?
And they're 7 and 9, and
slightly younger than the average bike shop employee.
And so what I did with the wheels is I would adjust the wheel. I would just randomly find a few spokes and loosen or tighten them, and put the wheel out of whack. And then the machine works both with measuring tension, but also works without measuring tension. Measuring tension just takes a little bit of time to master and to get good at that. So what I had the kids do is I had them put the wheel in the machine, spin the wheel around, measure the wheel without tension, and then use the quick true function, which picks just the 4 most important spokes to make the wheel as true as possible with just 4 adjustments. And it tells you which spoke to go to, and then you just put the driver on the nipple, press the button, and every single one of the kids could use the quick true function and get the wheel within spec, is good enough to be able to go on the road. So I think that just gives, and I'm not suggesting at all.
You're not suggesting you're an advocate for child labor?
Exactly. I think there's certain laws around that, and I think if they're at home, they can do work for me, right? But you can't employ my 7 and 9-year-old to do work at the bike shop. Or I'm not at all suggesting that, because there's like I said, there's more to doing maintenance on a bike than simply making the wheel perfectly true. But just like anything else, it is I see it as a tool to be able to do those things more efficiently and to a high quality consistency.
So I have to admit, when I first heard about this and kind of saw some of the videos that you'd posted of using this, the initial impression that I got was that this was almost designed to be almost like a replacement for a good mechanic. But having gone through it, I guess I've got a little bit more questions about that now because. So yeah, like in theory, to recap, like the process is you put the wheel in, it takes digital snapshots of each side, and then it does the calculations, and then it tells you exactly which spokes to apply the driver to, and then it automatically turns the nipple however many turns it needs to go, and then you're basically done. It does still seem like there is room for human error, though. Like how foolproof is the whole process here? Because like you still have to turn the right spoke that it's telling you to turn, right? Like you have to, I was using a spoke holder to make sure there was no twist, stuff like that. And like you have to know how to use a tensiometer. Like how much training is required, and how much, I guess, how much potential for error is there?
Well, that's something we're building on, and so it's. We now have a product with all the basic features. It has a nice looking app interface on it, but some of those training aspects we're actually putting into the application. Where it actually guides you through that process, and and at each step of the level it tells you what to do. So it says place wheel high tension side to the left and press the button, and then you press the button and it spins around and it says flip wheel and press the button. And so that's one neat thing about it, is it can be both a training tool and a tool to do the work at the same time. And the other nice thing about it is that ultimately in the end you are measuring the wheel. And so if you pick the wrong spoke to turn, you turn the wrong spoke, well then it's not going to be within spec, and you can do it again. And to some extent you can do it as many times as you want. Of course there's a limit on there, and you might eventually do damage or round out your nipples, but to some extent, it doesn't really matter how you get to the end result. There really is only one end result. If I move the wheel left, I move it right, I move it up, and I move it down, and then I finally get it centered, that's going to be the same thing if I just went right to the center of the wheel. So it's I certainly wouldn't want to say that it's foolproof because at the same time you want to pay attention of very thin, round metal spokes. You have to hold them with a tool. You can't let them twist. You can damage the spokes in that case. So there's still a lot of common wheel knowledge, common bike knowledge that we can't train with the machine, that we certainly require of the employees of the bicycle shop or the manufacturer using it.
Right. So you're I guess to put in plainer terms, like it's not like you're trying to put a bunch of wheel builders and mechanics out of work.
We're trying to give people another tool to help build their business. If they're an independent wheel producer, they can be more efficient and they can build more wheels, or they can have more time to do something else. If they're part of an organization, of a bicycle shop, they can spend less time, less effort. The other thing is the effect that wheel truing has on your hands and your wrists. We've dealt with that here at Berd back when we were doing all of our truing by hand. That it's not something you can do forever. With carpal tunnel and other injuries that you can have based on overuse. Being able to, for people being able to hold on to the drill, press the button, you don't have to ever turn your hand. It's also a help there. But then if you're saving time, that means you can do something else to help build the business, sell something else at the shop or other maintenance or whatever it might be.
Right now, with some of the math that we were talking about earlier, there does seem to be some limitations as far as like the math that it's doing. It's based on the information that it's provided, right? And it kind of has to know how many spokes there are and kind of like the geometry of the hub and that sort of thing. Like you do have limitations as far as how many different kinds of inputs you have right now, right? Can you like, I don't know, if I were to take like a Campagnolo wheel with their G3 triplet lacing or something, like I didn't see any input for that in there. So like where's all that right now as far as the development process?
Yeah, so the way the machine works is that it starts with a recipe of the wheel. And so the recipe defines exactly how the wheel is going to move when you turn a spoke. And so that's dependent on the type of material you have for your rim, carbon or aluminum. It's dependent on the depth of the rim. It's dependent on the number of spokes. Like you said, like the G3 wheels, if you have paired spokes or 2-to-1 lacing, it's dependent on the width of the hub. Every single one of those factors affects how the wheel moves. Some of them affect the way it moves in a larger extent, where you have to take them in account to be able to use the machine. Other ones affect it in a smaller extent, where you might be able to true it a little bit faster, like maybe just one round in a quick true versus 2 full rounds in a quick true, for example. But you'll still get to the same end result. So the way that the machine works is it takes all of the data on the machine. It actually sends that data to the cloud. It performs the calculation on how to turn every spoke in the cloud, and then that information gets sent back to the machine. And right now we have, on our machines that we're providing today, there's only like 400 recipes in sort of those combinations.
Which might sound like a lot to a lot of people, but like there's an awful lot of different permutations of hub, wheel, spoke combinations out there.
It's not that many. And so we just at the moment we have a program for sort of a good base of standard wheels with evenly spaced spokes, the same number of spokes on each side, all of the basic types of metal spokes, of course Berd spokes too, and just with those basic combinations. But like I said, even a wider hub, for example, it very slightly changes the way the wheel works. At Berd, actually, we true all sorts of different wheels, and we use essentially one program for every 28-spoke wheel, and it works well. It could go a little bit faster if we had everything programmed in. It's not really necessary. So the way that we do it right now is we have 4 different things that you have to select that are relatively easy to be able to select and pick pretty quickly. So it's the number of spokes, the type of spokes, which is just really the diameter is the important thing. And so it could be a DT Swiss Aerolite or a Supreme CX Ray, which are essentially the same spoke. Either one is fine. It's just a bladed 0.9 millimeter spoke. Then the rim type either carbon or aluminum, and the wheel size. So those are the basic things right now. But because it's an application and we're constantly updating it, and because we're doing things in the cloud, we're constantly adding more to that, both through our experimental data and our models and some of the data that we get back and how well the machine works. And it's just a matter of time before we have all of the reasonable combinations. And not to mention, we also have ways to be able to, for something very unique, we can train the machine to work with that as well.
So this thing does have to be connected to the cloud then, right? So like, what if you're like, I don't know, like are teams buying these things? Like if you're out in a venue somewhere and you have no cell signal, like could you use this right now?
So right now, no. Although it's becoming less and less common that you wouldn't actually ever have any internet.
For better or worse.
Exactly. With those, and we've been talking to some of the teams who have interest in using it, and they always have internet, Starlink, and they've always got a generator. So we've got power, we've got internet, but right now that is a current limitation, is that everything is going through the cloud.
So what are your long-term goals with this thing? Like, do you ultimately hope that this is in like, kind of every higher quality shop, or like, in assembly factories? Like, I mean, what do you kind of like, what's your vision for where this thing's going to be?
Yeah, we'll see. We think there's a lot of potential for it. So, we'll sort of let the customers guide that and see where people want to see it. But I do think that there's a big potential for it to be in a lot of different places. And one benefit of that is that there may eventually be some abilities to actually to track wheels, to sort of follow where they go throughout their history, and maybe even have the ability to say, well, this wheel was built here, it was trued here, and now it's over here, and see, oh, this wheel's had good maintenance on it over time. These are sort of longer things, but I just think there's a potential to add even more value to the both the wheel producers and also the bicycle shops to use it.
Do you expect any pushback at all? Because I could, on the one hand, like you mentioned that P&K Leah truing stand, and I've used that too, and for sure that accelerates the process of wheel building. Just again with those nonlinear gauges. And I could see it from the perspective of a long-term wheel builder, like they would look at like, this is a great tool. It speeds up my work. It doesn't really replace me, my skill, that sort of thing. It almost seems like TRUDI goes certainly a step further in that, in that, again, it does those calculations for you, and it sort of just tells you what to do. So to some extent, like, does it in any way kind of like devalue or like lessen the experience of a good wheel builder?
I'm sure that it could be thought that way. When you ask if there's pushback, absolutely. I'm sure there'll be pushback. I don't think there's anything
naturally, sure,
that we've done or that anybody does that doesn't have any pushback, because it's definitely something new. In many ways, it's a totally new tool to be able to do something a different way, and so that changing the way people do things, I think, yeah, definitely.
Are you? I know that you have been talking about this thing for a while. You've had it at a handful of trade shows like CABDA, Taipei, that sort of thing. This is the first time I have had the opportunity to see one in person and play with it. For anyone who is interested in this, like, do you have are any of these out in the field already? Like, can someone go to your website and see where they are and just kind of like check it out? So
like I mentioned, we have about 10 machines that are out in the field right now of the previous generation.
Right, because realistically, you're just getting going with this.
Yeah, of our machines. We have about 3 or 4 of the current generation now that are out in the field, and we have 50 of them that will hopefully be out in the field here within the next month or so.
Because it looks like a lot of them are like kind of pre-sold or pre-ordered already, right?
Yeah, of this first initial batch of 50 units, they're just about all allocated at this point. So there's not a lot of places you can go right now to see one. But of course, as we go forward, that'll change.
So are you hoping for like hundreds, thousands? What are you thinking?
Yeah, I think there's a potential. We've got we've got plans for at least a few hundred in production this year. So we'll start there.
Okay. Well, it is pretty neat. Like I will say, like it definitely kind of blew my mind when I first started using it. It's pretty impressive. I guess certainly as anything that's in kind of like an R&D phase, like it sounds like you're going to be making continual improvements on it. It's like, I guess as part of that purchase price, there's like a recurring monthly fee for like updates and hardware updates, that sort of thing, right?
That's right. Yeah, and that ranges. Right now it's $29 a month for the basic system that would be used in a bicycle shop, up to the enterprise level which isn't available quite yet with those features, but giving people the ability to actually incorporate it into your API to integrate directly with your sales system that you might already use to put those reports in with an order, and be able to run custom reports, create custom reports with it. So, between the service added for that customization, but then also the fact that we are very devoted to making this machine current and useful forever. It's not going to be something that stops working in a year because we don't provide any updates for it. And that's the purpose of that, is that recurring fee is not only for the updates that you're getting for your machine on the software, but if there's things that change on the hardware that are necessary, those are all going to be part of that, so that we can fully support that and continue to give a great service on a machine that you've invested in.
Well, like I said, I'm super intrigued and definitely pretty impressed after using it myself a little bit. I guess it'll be interesting to see how many of these we see out in the field. Charlie, thanks so much for the deep dive and the run through on this thing. And yeah, we'll see how this goes. I'm excited for you to see where this ends up.
Thank you, James.